All right, so this video is the exam review for our third exam, the last test we're going to have for the semester before finals. And so I just want to go over what to expect as usual. First of all, the topics will be everything since exam 2, obviously, and that means optics. So this exam will be on optics. You can expect, just as before, probably 5, 6 questions, something like that. All calculation style. So no surprises. It'll be formatted and look just like the other test you've had, but it is on optics. So what did we learn in optics? Well, of course, we learned that the mathematical function that describes a wave is, let's say, y equals a sine kx minus omega t. So you should be able to either tell me what the different characteristics of a wave are given the mathematical functional form. So can you tell me which of these things is the frequency, which is wavelength, what's the velocity of the wave, what's the maximum amplitude? Or given that data, so you're given a wave whose maximum amplitude is 2 meters, it has a wavelength of, 1 millimeter and a frequency of whatever, and I want you to write down a mathematical function. So be able to go back and forth with that stuff. So of course you need to know wavelength / wave number, frequency, velocity, amplitude. Then we had polarization. So the law of Malus, I equals I naught cosine squared of theta. Given a series of polarizing filters, you start with light polarized in this direction. How much light, or what's the intensity of the light that gets through the system? For this one, you can expect something, a page. That page may have 5 or 6 different examples. For each example, give me the intensity that makes it through. Next, we had refraction. And refraction, of course, was Snell's law. So these problems were the type light is incident on the surface of glass at an angle of 40 degrees. Calculate the angle of refraction. Or maybe a 3-layer system. So light goes from air into water, and then from the water it goes into glass. Give me the angle that the light makes into glass. All of these are Snell's law. Also, a different form of a Snell's law question is critical angle. So calculate the critical angle in water, or calculate the critical angle of glass. Or even, light goes from glass to water, what would be the critical angle in the glass for that particular problem? And so if you remember, this is just Snell's law, where you're looking for theta 1, what is the critical angle, given that theta 2 is 90 degrees. The light just skims the surface. So that was refraction. And then the last are the imaging problems. And with imaging, of course, we had mirrors and lenses. And for each of these problems, for instance, you're given a system. So there's an object placed 10 centimeters from a concave mirror whose focal length is 15 centimeters. Where will the image be formed? And, give me the four characteristics of the image. So you need to calculate the image distance, where it's formed. Is it a real image or a virtual image? That is, on what side of the mirror is it? Is it magnified or minimized? Is the image bigger than the object or smaller than the object? And is it upright or inverted? Is the image the same direction as the original object, or is it upside down? And so we saw you could draw it out, and you should be able to draw out the ray tracing, but also you should be able to do the analytical method, which is calculate the information. How do you know if the image is real or virtual? Well, you look at the image distance. If the image distance is positive, it's a real image. If the image distance is negative, it's a virtual image. How do you know if it's upright or inverted? Well, upright has a positive magnification. Inverted has a negative magnification. Things like this. So these are the topics for our last test. As I said, you can expect 5 or 6 main questions. One of the questions, the polarization, may have 5 individual examples in it, but that counts as one big question. But you can see we have 4 main topics. So you're going to get at least one from each topic, and a couple of topics may have 2 different problems associated with it. Now let me go ahead and I'll do a couple of examples, just so we could see what these types of problems may look like. So let's try an example like this. A wave of max amplitude (2 meters) is traveling with a velocity of 400 meters per second. If the frequency of this wave is, let's say, 200 hertz, write the mathematical function for the wave. Okay, so this is first topic about waves. Of course, this is all on optics. Optics is light, and light is a form of a wave. It's one of the examples of a wave. So we need to know how waves work. Well, the mathematical form, as I've already shown, looks like this. Y equals A sine omega t minus kx, or kx minus omega t. I've had questions about this, which order, because if you look online, you look in textbooks, a lot of times it's omega t minus kx, and I've written kx minus omega t. Let me just say, either order you write it is right. It does not matter. For our purposes, you don't have to worry about it. You could either do omega t minus kx or kx minus omega t. The most important thing is to remember k goes with x, so k, what does it represent? It's the wave number, which is like wavelength. So the wavelength thing is the thing multiplying the x. Omega goes with t, so the frequency thing goes with the t term. I will be able to look at your answer and tell, which order you write this. But don't worry if you write it this way and I write it this way, or vice versa. They're the same thing to me. Okay? I just wanted to remind you. So let me just go ahead and keep writing it the way I've been writing it, which is kx minus omega t. But as I said, if you write it the other way, that's fine too. If you're looking on YouTube and you see another professor doing a problem like this, and he writes it in the opposite order, that's right. It's fine. Okay? All right, so that's the functional form. What do these things represent? Well, here's amplitude. This is wave number, which is 2 pi over lambda. And this is angular frequency, which is 2 pi times frequency. Okay? So those are the three things I need to write, I need to put into this functional form. I need to know what those three numbers are. So how do I get this stuff? Well, first of all, what am I given in the problem? I'm given the max amplitude is 2 meters, so that's good. I already know. A is 2. That's done. I'm given velocity of 4, so velocity of 400 meters per second. Well, I don't have anywhere in this function about velocity, so let me leave that alone for now. I'm told the frequency is 200 hertz. 200 hertz is linear frequency. If it was omega, angular frequency, it'd be radians per second. We're given hertz here, so that's frequency. F, I'm told, is 200. Okay. But I don't want frequency and I don't want velocity. I want K and I want omega. Well, look at F, frequency here. I know omega is 2 pi times F. So that's 2 times pi times my F, which is 200. So I have 400 pi is my omega. Now, if you want to use your calculator, plug in 400 times pi and get a decimal thing, you can do that. That's fine. If you want to leave it as 400 times pi, just because it looks prettier, you can leave it as 400 times pi. I'll accept both answers. Well, now I have omega. Good. I have A. That's good. Now I need K. K can be gotten from lambda, which is wavelength, but I don't have anything about the wavelength here. What I do have is this velocity thing, and I know that velocity is frequency times wavelength. So I can calculate the wavelength from this and then use the wavelength to give me K. So that's what I'm going to do. Let me do it down here. So velocity equals frequency times wavelength, which means wavelength is velocity over frequency. The velocity is 400, frequency is 200, so I get a lambda of 2. Now that I know lambda is 2, I use the fact that K is 2 pi over lambda, which is 2 pi over 2, which is pi. Great. So now, what do I have? I have A, amplitude. I have K, which is pi. And I have my omega, 400 pi. Perfect. So let me plug it all in. 2 sine K, which is pi, times X, minus omega, which is 400 pi, times T. And there's the mathematical function. And there you go. Given information, characteristics about the wave, you should be able to create this mathematical function. What is the amplitude, or what's the max amplitude? What is the velocity? What is the frequency? What is the wavelength, the wave number, angular frequency? Things like this, you should be able to take the information and get the stuff that you need for your problem. And vice versa. You should then be able to look at what's boxed as the answer, take this mathematical function, and write out for me what are all the characteristics. What are the characteristics of this wave? Now, this wave has a max amplitude of 2 meters. Its wave number is pi, and its angular frequency, omega, is 400 pi. You should be able to do that. All right, let's try an example of polarization. Well, polarization, we're going to have something like this. Let's take one of the harder examples. We're starting with unpolarized light, and I want to go through this series of polarizers. Okay. So first I want to go through 60 degree. Then I want to go through horizontal. Then I want to go through 45 degrees. And I want to go through 30 degrees. All right, so the question is, given I start with an intensity I, or I naught, I should say, what is the intensity of light passing through this system? All right, well, here, what are we starting with? We're starting with light that's unpolarized. Because of that, unpolarized light is a special case. The special case is, no matter what the first filter is, the amount you get out is always 1/2. Okay? So, I start unpolarized and I'm trying to get through 60. How much intensity will I have? 1/2 because of that guy. Now that I'm through, I'm now polarized at 60 degrees because I got through. Now what do I want to do? I'm light, that's at 60 degrees, and I want to get through the next polarizer, which is horizontal, 0 degrees. So that means I'm going to have a cosine squared of what? I'm starting at 60, and I'm trying to get through horizontal. I've done it. I'm now horizontal. And now again, I'm horizontal. I'm trying to get through the next filter, which is 45 degrees. So I have cosine squared again. And what am I doing? I'm at 0, and I'm trying to get through 45. Done. I'm now through it. I'm now at 45 degrees. I'm now 45, trying to get through the last filter, which is 30, so another cosine squared. I'm starting at 45, trying to get through 30. And I'm now finished. Now all I have to do is stick this stuff in my calculator. So what do we have? Well, I naught, that's just the original intensity. We have 1/2 sitting there. The first thing is cosine squared of 60. 60 minus 0 is just 60. The next one is cosine squared of 0 minus 45 is just 45. Just note, here's a mathematical thing for you. Cosine of A is the same as cosine of negative A. Okay? So the cosine of a negative number is the same as cosine of the positive number. So even though technically it should say cosine squared of negative 45, I know that I can also write cosine squared of 45 and it'll be the same number. There are no negatives here. So I just prefer to write positive 45 so that it doesn't look so messy with the negatives. You won't have any negative numbers with any of this stuff. So just make them positive. All right. The next one, cosine squared, is 45 minus 30, which is 15. And so this is what I have to write. So how would I do it? I would say this term, and this term, they're squared. So I'll do cosine of 60 times cosine of 45 times cosine of 15 and get a number. I'm going to take that number and I'm going to square that number. All right. So now what I have is I naught times 1/2 times 0.11663. Okay. So multiply that times 1/2 and I get I naught times 0.058. And there we go. Now, however you want to do these cosine squares is up to you. Note the 1/2 is not squared. The cosine squareds are squared. So you could either do cosine 60 times cosine 60 times cosine 45 times cosine 45 and so forth. Or you could do cosine 60 times cosine 45 times cosine 15. And then after you get this answer, you square it. You could do it that way. That's how I did it here. Or you could do cosine of 60, square that number, times cosine 45, square that number, times cosine 15, square that number. Any of these three methods will work. Then, of course, don't forget to multiply by 1/2 afterwards. So it's up to you how you want to manipulate your calculator, which is the easiest way to put it all in. But remember, cosine squared means cosine of the number times cosine of the number. All right, so that's polarization. What about refraction? Let's do another example. Let's take the example. Light is incident on the surface of a pond at an angle of 30 degrees. And I want to know what is the angle of refraction. So I'm going from air to water. So what do? I use Snell's law. N1 sine theta 1 is N2 sine theta 2. What's going on in the system? I'm going from air, so all the 1 stuff is air, to water. All the 2 stuff is water. So N1, that's the index of refraction for air, which is 1. Sine theta 1, the angle of incidence coming in is 30 degrees. Equals N2, I'm now in the water, 1.33. Sine theta 2, well, theta 2 is the thing I'm trying to calculate. So I solve for theta 2, and I get theta 2 is inverse sine of 1 divided by 1.33 sine 30. Right? I divide over the 1.33, and then I inverse sine everything. So 1 divided by 1.33 times the sine of 30, inverse sine of that business gives me 22.08 degrees. Does it make sense? Well, I'm going from air to water, so I'm going from less dense to more dense. My angle should get smaller. I was at 30, I'm now at 22. My angle got smaller, so things make sense. I can be fairly confident this is correct. So that's Snell's law. Refraction. Pretty easy. All right, last example. We'll do an example of imaging. Let's see. Do I want to do mirrors or lenses? Let's do a lens. Let's say an object is placed 10 centimeters from a converging lens whose focal point, or whose focal length, I'm sorry, not focal point, focal length is 25 centimeters. calculate the four characteristics of the image. Okay. So what are the four characteristics? The image distance, is it real or virtual? Is it magnified or minimized? And is it upright or inverted? First thing, and also let's try to draw it. We should be able to draw this too. You're probably going to be asked to draw the ray tracing. So we start with the principal axis. There's the principal axis. Here's our lens. Converging lens means it bulges out, so it looks like this. Where's the focal length? Let's say focal length is here. Okay, so from here to here is 25 centimeters. And the object is at 10, which is, let's say, here. So from here to here, that's 10. Object distance, focal length. All right, so we need to do our ray tracing first. If you remember, we can do 2 or 3 main lines. The first line is always parallel to the principal axis until you hit the lens. And then the light is going to go through the lens and it's going to bend. It'll either bend upwards or downwards. In this case, it always bends towards the focal length. So it'll try to hit over the focal point. It'll hit this focal point over here. There's our first line. Our second line, let's do it in yellow, goes from the object straight through the center of the lens. Okay, so there we go. Now notice these two lines are getting further and further apart. They don't connect. So that means I'm not going to get a real image. Real image is an image that would, the light rays focus on the right side of the lens. But where do they connect? Well, now what I can do is extend these lines backwards. These are fake, but I just extend them backwards. And we can see right here, they're connecting. So that means we should have an image right there. Now, of course, if I was very accurate, I'd have a, if I was being very careful, I should say, I should have an accurate view of the image distance and all of that. But for our purposes, this is a good drawing, good kind of sketch of the ray tracing. So that's done. Now what we want to do is the analytical stuff. We want to mathematically figure this out. So we start with the imaging equation. 1 over f is 1 over object distance plus 1 over image distance. I want to, 25. I want to calculate the image distance here. So I have 1 over 25 equals 1 over 10 plus 1 over di. Bring the 1 over 10 over. 1 over 25 minus 1 over 10 equals 1 over di. All right, 1 over 25 minus 1 over 10. 50 is the common denominator, so 2 over 50 minus 5 over 50 is negative 3 over 50 equals 1 over di. So di must be negative 50 over 3. All right, so we now know where the image is located. 50 divided by 3 is 16.67. So had I been accurate, I would find that the image distance is 15 centimeters to the left of the lens. Of course, on my drawing, that should be somewhere like here. I wasn't very accurate. You can tell my lines are not perfectly straight, but at least I see it is a virtual image. The image is on the left, so it's okay. It's okay. But this answer gives me two answers. First of all, the image distance. Where is the image? It's 50 over 3 centimeters to the left, because it's negative, to the left of the lens. The other thing it tells me is this is a virtual image. And I know it's virtual because that image distance is negative. A positive image distance is real. A negative image distance is virtual. All right, so I have two answers. I need two more. Now I look at magnification. Magnification is minus di over do. Okay, so negative, what's the image distance? Negative 50 over 3. Divided by, what's the object distance? 10 centimeters. So, what do we have? We get positive 5 over 3, I believe. There's my magnification. So, what does this tell me? This magnification tells me two different things. First, because 5 over 3 is a number that's bigger than 1, it's 1.67, that means the image is magnified. Okay? The magnification, the number you get, if that number is bigger than 1, then it's magnified. Look at my picture. My image arrow is much bigger than my object arrow. So yeah, it should be magnified. Perfect. But what's the other thing it tells me? The other thing I get from magnification is what's the sign? Is this a positive number or a negative number? In my case, the magnification turns out to be positive. Positive means this is an upright image. And again, if you look at the picture, the blue arrow, the image, is pointing upwards like the original object was, so it's upright. It did not invert. However, if when I calculated my magnification, the number turned out to be a negative number, then it'd be inverted. So there we go. There's my four characteristics. Image distance, virtual or real, magnified or minimized, and upright or inverted. How do I get them? Use the imaging equation to calculate image distance. Once I know image distance, if it's positive, it's a real image. If it's negative, it's virtual. Next, use magnification. Calculate the magnification. Once you know the magnification, if it's positive, it's upright. If it's negative, it's inverted. Secondly, look at the number. Forget about the sign. Just look at the number itself. If the number itself is bigger than 1, it's a magnified image. If it's less than 1, it's a minimized image. And of course, if it's equal to 1, it's the same size. And that's how you get your four characteristics. So two little equations, plug in the numbers. Once you get the answers, those two answers tells you four different things. And there we go. This is what you can expect from the test. As you can see, going through this fairly slowly, I could have done this a little quicker if I didn't have to talk my way through it. I was able to do 4 example problems. This video's been about 30 minutes. Some of it was at the beginning explaining things. But you can see, these aren't too bad. Now, there's different topics, and each topic takes its own thing. So that means you have to study and make sure you understand each individual topic. But once you've done a few practice problems, you're going to find that each topic is pretty much done the same way. Refraction problems all use Snell's law. So as long as you know how to use Snell's law correctly, any refraction problem I give you should be okay. Imaging, well, you can have lenses or you can have mirrors. Either way, you're still using the imaging equation and you're still using magnification equation. And you're always answering the same questions. What are these four characteristics? Polarization, law of malice. It's always cosine squared of the angle. So whatever system of polarizers I give you, you go through the same steps every single time. It's just that each system will have its own angles. So anyway, I hope this exam review helps. Again, the exam will be Saturday, or this weekend, I should say. It'll be posted Saturday morning, and you'll have till 11:59 p.m. Sunday to submit it. No late work, nothing like that. So if you're worried you won't be able to submit it on time Sunday, then do it on Saturday and submit it on Saturday. I'd rather you submit it as early as you can to avoid being late and not getting credit for your last test. Once this is done, all that's left is to review for the final exam. And of course, you'll see a video following with that kind of information. So I wish you luck on the studies. Practice these problems. Practice the problems that are on Canvas. Go back over the homework problems that were assigned for these particular topics. And just get a lot of practice in. If you have any questions, always email me, and I'll be happy to help however I can. But until then...